Hello friends, today's question: 5.6 liter of helium gas at STP is adiabatically compressed to zero point 0.7 liter. Taking the initial temperature to be T1, the work done in the process is. So this is a adiabatic process. So we are going to start with the standard equation for adiabatic process, and from that we are going to find out the relationship between T1 and T2, and then we are going to find out the work done which is finally asked in the question. So we start from that for adiabatic process. We have T V gamma minus 1 is equal to constant. Here T is the temperature of the gas, and V is the volume of the gas. Gamma is the adiabatic index, which is given as the ratio of Cp by Cv. Gamma is our Cp upon Cv, and the helium is our monatomic gas. Therefore, the value of gamma is our 5 by 3. You can say for helium, which is our monatomic, value of gamma is our 5 by 3. So we are also given that the initial volume is our 5.3 liter. So that is our V1. So V1 is our initial volume, which is given as 5.6 liters. V2 is our final volume, which is given as 0.7 liters. And we assume that T1 is our initial temperature and T2 is our final temperature. So we can modify the adiabatic process equation for V1, V2 volume and T1, T2 temperature, and we can write it as that our T1 V1 gamma minus 1 is equal to T2 V2 gamma minus 1. So we substitute value of the volume. So we say T1 and volume V1 is given as 5.6, gamma is our 5 by 3 minus 1, T2 0.7 and gamma minus 1. So from here we can write that our T1 will be equal to T2 0.7 divided by 5.6 and this whole raised to power 2 by 3. So this gives us the relationship between T1 and T2. So we can write our T2 is equal to 4 times T1. Now we are going to use the relationship of the equation of the work done. So we can say work done, that is W, is equal to over N R delta T divided by gamma minus 1, and which can be written as N R T2 minus T1 divided by gamma minus 1. Now in this case we are supposed to find out the value of n, and the n is given to us as, that is the number of moles. Okay. So we are going to find out the number of moles that will be present in the helium. Okay. So we can say from here that n is the number of moles and number of moles of helium gas. Helium gas. And at STP, we can say that at standard temperature and pressure, 22.4 liters of ideal gas is equivalent to 1 mole. Is equivalent to 1 mole. So we can find out that value of n will be equal to V1 divided by 22.4, and V1 is given as 5.6. 22.4, this comes as 1 by 4 moles. So now we can easily solve the value of, or you can say the equation of the work done. So if we can say, therefore the work done will be equal to 1 multiplied by R. T2 is our 4 times T1 minus T1, and this comes as 4 multiplied by, we have 5 by 3 minus 1. So this will be equal to, this comes 3T1 R divided by, and this is 4 2 by 3. Therefore the work done will be coming as 9 by 8 R T1. So this is the work done. We can say this is the required work done. And the options that are given to us, option number A is the correct option. Option A is correct. So this completes the question. Thank you.